On the back page of this note sheet here, we're going to talk about finding z-scores from percentiles. All right, so just real quick, what is a percentile? If I say that my child's height is in the 70th percentile, okay, let's take my son for an example. Suppose my son is in the 70th percentile for weight. All right, if he's in the 70th percentile, that means that he is heavier than 70% of all other kids his age, all other male children his age. All right, so that's what we mean by percentile. Now, what we can do with the normal model is we can work our way backwards from percentile to z-score. So we can answer questions like this. Again, we have the same situation. Mean is 69.2, standard deviation is 2.8. We want to know the shortest 20% of adult American men are less than what height? Okay, in other words, if I'm thinking about the normal curve, what is the z-score, or the standard deviations away from the mean, of 20% of the men? Well, you might look at this and you might approximate it, right? So here's at -1, there is about 15% of the men would be to the left of -1 standard deviation away. We'd expect it to be somewhere in here between 0 and -1, but we don't know exactly where, so let's figure that out. Okay, so the way this works is, I'll just give you a reminder here. Z is equal to x minus mu divided by standard deviation. And we're going to use the command in the calculator called inverse norm. So the way this works is it looks like this. Okay, and what we do is we plug in a percentile. Okay, so if we want the shortest 20% of adult men, that's basically asking us what is the 20th percentile. So we'll do inverse norm of 0.2. So in your calculator, you're going to go second vars key down to inverse norm. You're going to put in 0.2. That tells you the z-score. So the z-score is -0.842. Or we'll just go -0.84. We probably only need 2 decimal places on for a z-score. So if the z-score is -0.84, I can use this formula to work my way backwards to figure out, well, what is the height? So in this formula, I now know z, I know the mean, and I know the standard deviation. So I should be able to work back to the height, and that will look like this. So we'll plug in z. So z is -0.84. That's going to be equal to the mean, the data point minus the mean, which is 69.2, divided by the standard deviation, which is 2.8. If you solve that for x, then you end up with x equals 66.8 inches tall. Okay, so 66.8 inches is the 20th percentile for American adult men. Okay, let's go check the next one. How tall are the tallest 1% of American men? Well, the first thing you need to do is interpret this as the 99th percentile. Okay, because remember, 99th percentile means if you're in the 99th percentile, that means that you're taller than 99% of men. Okay, so what we're going to do then is go inverse norm of 0.99. All right, and that'll calculate the z-score. It turns out that z is equal to 2.33 when you do that. Actually, there's a better way to write this. 2.33. Okay. And then you're going to use that z-score formula just like we did above to figure out what the data point is. So you'd go 2.33 is equal to x minus 69.2 divided by 2.8. Solve that for x, and you get x is equal to 75.7 inches. Okay, there is a really straightforward type of example here in the assignment, and but it's almost so simple that it's confusing. So if you want to find the probability of z being greater than 1.5, that is just a greater than problem where they've given you the z-score. There's just no extra work to do. They've given you the z-score. So all you need to do in your calculator is go normal CDF, and it's a greater than question, so you're going to go 1.5, comma 5. All right, and so that gives you 0.067. Right? And that's it. So if you get a problem like that, just do this. Okay. Last one. Let's talk about Wisconsin's Megabucks lottery for a second here. Okay. In the lottery, you pick a number between 1 and 49. Sorry, you pick 6 numbers from 1 to 49. And if they match the numbers from the drawing of 6 numbers, then you win. Okay. So in the history of the game, there has been 13,230 numbers drawn. Okay. The number 9 was a winner more often than any other. 295 times it was a winner. So let's see. If 9 was the most frequent number picked out of the numbers 1 to 49, is it possible that 9 is actually a lucky number? Is it likely that 9 is one that you should pick more often than not because it wins so much more frequently? Well, let's figure this out. First of all, let's figure out what is the average number of times that you would expect any number to win. All right, so what we need to do then is figure out the mean. And by the way, this is a binomial distribution because either you win or you don't. All of the games are independent. All the drawings are independent. And we can figure out the probability of winning on each draw. It doesn't change. So we'll figure out the average number of times. That will be equal to 13,230 numbers that were drawn times the probability of getting any one particular number. So that's 1 out of 49. And so that's going to be equal to 270 times. Okay, so we would expect on average a number to be drawn 270 times. This one was drawn 295. Okay, so well, let's figure out, is that close or far away? And to figure out how spread out the data is, we use standard deviation. Again, since it's binomial, we can use that formula from the previous lesson. And that formula was square root of n times p times q. Okay, n is 13,230. P is 1 out of 49. Q is 48 out of 49. Right, when you calculate that, you get a standard deviation of 16.26. Okay, well, we're getting closer. This tells us our standard deviation. Let's figure out our z-score. Let's figure out the number of standard deviations away from the mean that 295 is. All right, so let's go. Z equals 295 minus 270 divided by the standard deviation, which is 16.26, and you end up with 1.54 for the z-score. Right? This is not unreasonable, right? We know that 95% of the data is going to be between -2 and 2, a z-score of -2 and 2. We have a z-score of 1.54, so there's going to be, it's not unreasonable to think that you might have a number show up 295 times. So this is not a lucky number. This is just an artifact of randomness. If we got a z-score of 3 or 4 or 5, I mean, the higher the worse it is, right? But a 3 or 4 or 5, then we would suspect something fishy was going on. But otherwise, 1.54, that's perfectly reasonable z-score, and 295 times is not a statistically weird or statistically significant number of times for it to show up.